All right, this is number 18 on page 484, lesson 9.3. We're going to do it using the p-value method. A researcher claims that the variation in the salaries of elementary school teachers is greater than the variation in salaries of secondary school teachers. Secondary would be high school. A sample of the salaries of 30 elementary school teachers has a variance of $8,324. A sample of the salaries of 30 secondary school teachers has a variance of $2,862. At alpha equal 0.05, can the researcher conclude that the variation in the elementary school teacher's salaries is greater than the variation of the secondary teacher's salaries? Use the p-value method. All right, so p-value method, we write out our hypotheses first, then we find our test value. Step C, we find our p-value. Step D, we reject or not reject the null. Step E, we summarize our results and talk about the claim. So those are your 5 steps. We've got elementary teachers, and we have secondary teachers. Let's get the information down first. Again, this is number 18 on lesson 9.3, and we're going to do the p-value method. All right, information they give us. Both sample sizes are 30, so N sum 1 would equal 30, N sum 2 would equal 30. They tell us that the variance, sample variance for elementary teachers is $8,324. What's the symbol for sample variance? S squared. Yep. So that number's already been squared. If you wanted the standard deviation, you have to take the square root of that. So we'll call it S sub 1 squared. So that's our first sample. S sub 2 squared. If it helps you to put parentheses here, you can. Make sure you understand that that's a variable squared, but the 2 is just a subscript. For secondary teachers, looks like $2,862. Looks to me like the secondary salaries vary less. If you look at these 30 secondary teachers, their salaries are probably closer together. Where you probably have a bigger spread over here because of a bigger variance. Right? We're going to find out here in a minute. That's what we're going to test. So for 18, step A, we're going to write our null and our alternative. Again, it says, can the researcher conclude that the variation in the elementary school teachers is greater than the variation in the secondary school teachers? So it sounds to me like they are claiming that this variation is greater than this variation. Now you look at these two numbers and you might say, well, that's obvious. 8,000 is more than 2,000. But remember, we're talking about for all teachers out there, not just these 30. We're saying, is this evidence strong enough to say that the variance of all elementary school teachers is greater than the variance of all secondary school teachers? So we're making a claim about the population variance. So population variance 1 squared is greater than population variance sub 2 squared. That's what we're going to claim. So then, of course, the null would be the opposite of that. Questions about that? And to me, it looks like the claim is going to be true, but we have to check it out with statistics to make sure that this is big enough. This is enough bigger than this to say that that claim is supported. Okay, step B is the test value. So you're going to use, you have at least 30. Anytime you have at least 30 in your sample, you can use these scores. So you're going to start, get your formula sheet out. Excuse me, not your z-score. You're going to use your F score. F test is what I mean. When we deal with variances and we're comparing two sample variances, we use F. Now, which variance goes on the top? Remember, it's the larger one. So you're going to put 8,324 divided by 2,862. We don't have to square those because they've already been squared for us. If they weren't squared, then they would have called these standard deviations. But when they call them variances, that tells me they're already squared. Anyone know what that comes out to when you divide those two numbers?
2.91.
2.91. Thank you. Okay. Part C, we're going to try to find the p-value. Remember, the F distribution is skewed right. It's got a mean of 1. So 2.91 is somewhere out here. p-value would be this area right here. Okay? So now we have several charts we have to look at. We're going to set up a chart here. Top numbers are going to be alphas or areas. The bottom numbers are going to be f values. We're going to look at 0.10, 0.05, 0.025, 0.10, oops, 0.01, and 0.005. And we're going to go, and why don't you use the same assignments I gave you earlier as far as which one you should look up. So the first row, look up 0.10 f value. Second and third row is 0.05. Fourth row, 0.025. Fifth row, 0.01. And the last row, look at the 0.005. And we'll write these down. Anybody in the first row get that first one yet? Oh, we got to get degrees of freedom, don't we?
Yeah.
They're both 29, yep. Remember that the numerator is this one, so the numerator is your highest variance. So your degrees of freedom of the numerator is going to be 30 minus 1 or 29. Degrees of freedom of the denominator is 30 minus 1, which is 29. Okay? So you're going to look, when you look this up, you're going to look for 29 at the top of your chart and 29 on the left of your chart. And then you're going to look up your number here. Anybody know what this one came out to here?
0.01 is 2.65.
1.65. How about this one?
2.15,
2.49.
And 2.76.
People agree with that or not?
1.90.
1.90 here? Does that look right?
It's wrong.
Okay. So now, 2.91 doesn't fall between any of these, does it? Doesn't fall in here or here or here. It falls, 2.91 would fall out here. Because these numbers are getting bigger. But these numbers up here are getting smaller, aren't they? P-value is what? Less than 0.005. If it's one-tailed, if it was two-tailed, we'd have to double that 0.005. But it is one-tailed, right? Because we're up here with the graded at symbol. So for step C, we're going to say that our p-value is less than 0.005. So that means if the null is true, and there's only a 5 out of 1,000, actually less than a 5 out of 1,000 chance that we would get a test value at 2.91. 2.91 is actually, to have this drawn more accurately, 2.91 is way out here in the tail. I know that because I got this really small area here. 0.005 would be a very small area, wouldn't it? And we know our p-value is actually, that area is actually less than 0.005. So I'm way out in the tail. So you think I should reject or not reject? Reject. Yep. Your p-value is less than your alpha here. I didn't even have to look to see what my alpha was to know that probably, but what is alpha? 0.05. So 0.005 is way smaller than 0.05. So for step D, p-value is less than alpha. So reject to no.
Wait, so what do you find then?
Alpha in this problem is 0.05. Since the p-value is less than 0.005, it definitely has to be less than alpha. Erase this chart. So now, if I'm rejecting the null, that means we think it's false, which means we think the alternative hypothesis is true. So we'd say there is enough evidence to support the claim. Yep. There is enough evidence to support the claim that the variance is larger for elementary teachers. Actually, I'll say for elementary teacher salaries. And I'd be curious to know why that's true. I'm not sure. And maybe it wouldn't be. Maybe we did another study here. Maybe we wouldn't find that true. But that's good.